Claxon's Algebra 2 class. This is part 2 of graphing a rational function. I left you in the last section where I had set up my graph. All I had were the vertical asymptotes and that horizontal asymptote there. And I didn't graph that horizontal asymptote as a dashed line. Okay, I almost said shaded because that's what we're doing right now in Algebra 1, as a dashed line. I should have graphed that as a dashed line to show you that all asymptotes are graphed with a dashed line. I've divided it up now into 3 different tables here. A table for what is left, the leftmost part, okay, or what I like to call the left part. Looks like I tried to cross that out there. Approaching x equals -5 from the left. A middle part, approaching x equals -5 from the right, and that horizontal asymptote, or that vertical asymptote of x equals -1 from the left, and then the right part, approaching x equals -1 from the right. So hopefully you can see that with these 3 different colors. Let's go ahead and talk first about the left part and why I chose these values. I chose these values right here for the left part, which, by the way, I obtained simply by going to my graphing calculator. And if I'm on my home screen, I want to first make sure that my table is set. Okay, I want to set my table, so I go to the table set. I make sure that the independent variable is on ask, because I want the calculator to ask me what to put in for that independent, that x variable. Okay, my dependent variable, which is my y variable here, is going to be on auto. I want my calculator to calculate that for me. So I go to my table by hitting second and graph, which is the table function. You can see it right there. You have to excuse my cold today. And I like to enter in these values. And the reason why I picked these values, and I really should start all the way to the left. So we're actually going to start with like -100. At -100, what is the y value? At -100, the y value is very, 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 very close to that horizontal asymptote. And then as I go further and further right, I'm going up now. I'm going up. I'm working from left to right on the graph, so I'm going up at -10. That would be -10, Mr. Claxon. -10. At -10, I get a value of about -3/10. Okay, and I don't even bother graphing that. I'm just kind of showing what I'm doing here. At -8, well, what happens at -8? -8, I get about -5/10. So at -8, I get about -5/10. That point is about right here. So you can understand kind of what's happening here. It's very, very, very close to it. Crosses these 2 points. And then you can see that I graph -6, -1.8, -6, -1.8. And then what happens as I get so close, -5.1, about -20. -5.1. -5.01. So notice I'm approaching -5.000. Whoa. Let's go back and put that in. This is the great thing about these calculators. I can edit that in. You know, that just shows me -20,000. Wow, that's way down there, all the way down my toes. So you can see kind of what happens here with that left part. I should kind of have arrows on those to show that they do go forever. Notice that's not a 90-degree angle right here. Okay, just kind of, it curves. It's got a little U shape to it. And all I'm looking for is that you know the in general, what's happening. Okay, so you can draw that in general. And now I have the middle part here. The middle part are those x values in between -5 and -1. And what's happening there, if I plug all these values in, which I've started to do right here, okay, and I put in -4.9999, because I can't put in 5. Actually, 4.99, Mr. Claxon. Because I can't put in 5. So I get -4.99, 200. Wow, that's way up there. Way up there. So I know it's going to start way up there. And then, okay, let's go ahead and go to -4 Hopefully you can see this. Negative 4.9, I get about 20.26, right? Or about, can we just call that about 20? Okay, about 20, about positive 20. See, now it's kind of coming down now. Let's go ahead and go up one here, and let's say, okay, what happens at negative 4? Yeah, what happens there? Oh, about 2 1/3. Yeah. So at negative 4, I know up 2 1/3. Negative 4 up 1, 2. Okay, and 1/3. That's going to be a point. Oh, Mr. Claxton, you got to graph that in brown. Okay, the middle part is the brown part. I'm color coding. I want to be organized for you here. So you see that goes through that point, and then going back up. What about negative 3? And I'm just going to go ahead and enter in these values that I have in there. I didn't mean to write negative 33. Didn't mean to write negative 3. And then did mean to write, let's see, negative 2. Can I put in negative 1? What happens if I put in negative 1 here, if I get careless? Oh, I get an error message. Why is that? Because the function's undefined at negative 1. If I put a negative 1 in there, negative 1 plus 1 is 0. I know 0 times any value. Doesn't even matter, even though I know this is going to be 4. Okay, 0 times 4 is 0, right? Negative 4 over 0, that's not a defined value within mathematics. Okay, you're not allowed to divide by 0. So understand that's why when I get to negative 1 there's that vertical asymptote. But understand, so what starts to happen as we approach it? Let's see, I don't want to plug in negative 2. How about negative 1.1? Negative 1.1. Boy, do I struggle. 1.1. Okay, negative 1.1. All right, ooh, 10. It starts going back up, right? And then negative 1.01. Let's try that. Oh, going back up further. About negative 1.0001. All right, yeah, Mr. Claxton, we get the point. It goes way back up. So you kind of see how it makes that U shape there in the middle. Boy, that U shape goes back up. All right, and to finish strong here, I'm going to finish on the right part. The right part, I plug in these values, right? So I get negative 0.999, and then negative 9/10, right? Negative 9/10. It has a value, Mr. Claxton. It so desperately wants to be a number. Please state it as a number. What happens at 0, 2, and then let's check 1,000. Let's just go way out there. Get way out there. I'm going to delete that one. Okay, so this is in the table function. Understand the calculator's doing all the work for me. Oh my goodness, it accepted a value at negative 1. Oh no, it didn't. It just rounded. That's negative 1.0001. That's negative 1 and 1/10,000. That's right. Negative 1 and 1/10,000. That's not negative 1. If it were negative 1, we would get an error message. Okay? At negative 1, boy, that's way up there. So because that's way up there, whoa, actually I still should be negative 0.999. How about that, Mr. Claxton? Oh, there we go. There we go. Okay. I just had that one left over from the other one. It didn't make sense. Notice what's happening here. We start down here very, very, very low. Very, very, very low. And as we come up, we are going to make the turn. It's a very defined turn there. Okay, and we're going to head out that way, getting closer and closer and closer to the x-axis. This is actually kind of a goofy function. Many of you who explored it, if you plug in the value 3, you'll see that it crosses. Whoa! It crosses our horizontal asymptote, which isn't allowed. That's actually way more involved in rational functions than we want to be right now. So I'm not going to confuse you or bore you with that. Just know that as it approaches, we want general, as it approaches this from the left, this is what it's doing. Okay? And then it makes the U shape in the middle. I figured that out. And then starts down here very, 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 very small. Okay? And goes and approaches our horizontal asymptote. Hopefully that kind of helps you. Breaking that up into those partitions will help you to graph rational functions. Thank you for watching.